All right, we're gonna try a little lab here. But first, I want you to take out wood block sample problem. I gotta teach this first. It's like the boat problem. Number one is the flat bottom boat, the area is given, and the mass. So we're trying to figure out how far below the water surface is the boat bottom. So, because it's floating, we're gonna set this up Fg of boat equals the buoyant force, okay? So we're going to break that into mg equals rho fluid v fluid times g, right? And then we have our g is going to cancel. So it's really going to set up for m equals rho fluid v fluid. Now in this problem, the mass is 60. So we have 60 kilograms, which equals water. What we're going to use is 1,000 kilogram per meter cubed. And we can solve for the volume of the fluid. Okay, so the volume of the fluid equals 0.06 meter cubed. Now this also then equals what? The volume of the water that's displaced, right, is going to be the volume of the boat that's submerged. Now we know that volume can equal area times height, right? This is your length times width, but in this problem, area is given. So let's plug in now. 0.06 meter cubed equal, you see that the boat was 4 meters squared times h. See how the units match, meter cubed, meter squared, that'll be a meter. H equals 0.015 meters. All right, so that is number one. Now for two, you're just adding more mass. Okay, the fishermen get in the boat with their gear. It's a little ambiguous because it does say everything's a total mass of 300, but we're going to say this. It's 300 and the boat was 60, so we're going to start with 360. So we can go right to this step right here and say 360 kilograms equals the 1,000, sorry, it's getting a little small here, kilogram meter cubed times the V fluid. So the V fluid here ends up being 0.36 meters cubed, right? And then we're going to just take that next step. That's equal to the V boat equals A boat times H. So 0.36 meter cubed equals the 4 meters squared times H. Now H is 0.09 meters. That's how much it has gone down now. But the question doesn't ask that. It says how much lower does the boat go? So we would say, well, it already went 0.015, so we'll subtract the 0.09. That was the additional submersion there. So the answer ends up being 0.075 meters. Now, why did I do this? Well, this is a setup for a kind of modified lab we want to do here. It's called the Submerged Wood Lab. So if you want to take that out right now. Essentially, what we did was I took a wood block here. I got the mass, 0.9 kilograms. I got all this information is given to you. I measured the length, the width, the height, density of water is given to you also. So kind of using what I kind of taught you here and here, I want you to predict how far the wood will submerge if I place it in water. So you're really essentially kind of looking for this H right here. Okay, so use that data. Eventually, for part 2 of the lab, I'm going to place this piece of wood and you're going to see how close you get to that number. Okay, so part 1 of this lab, try to figure out the H based on the data that was given. All right, and then part 2 comes tomorrow.